We're surrounded by all this amazing technology that's tougher, faster, and smarter than ever. But have you ever stopped to wonder how we give a totally ordinary material, well, an extraordinary ability? Turns out, the answer is this hidden process, almost like a kind of high-tech alchemy that's giving everyday objects their own secret superpowers.
Right, so how do you do it? How do you take a basic piece of plastic or metal and suddenly make it unbelievably hard or self-lubricating or maybe even able to shield our most sensitive electronics? That's the big question we're diving into, and the answer is all about some really fascinating chemistry.
And the solution is something called electroless plating. Now, the key word there is electroless. Unlike the methods you might be familiar with, this process uses absolutely zero electricity. It's all pure chemistry. Think of it like a carefully controlled chemical recipe in a liquid bath that deposits a perfectly even metallic layer onto pretty much any surface you can think of, no matter how weird or complex its shape is.
A great way to picture it is to imagine a flawless suit of armor, one that perfectly hugs every single nook and cranny of an object, because it's literally being built from the atoms up. This armor isn't just sitting on top, it becomes a fundamental part of the surface, giving it a whole new set of skills. But honestly, the real magic isn't just the armor itself, it's what you can mix into it.
Okay, so this is where things get really cool. We're not just talking about applying a simple metal coating anymore. We're talking about creating incredibly advanced composite materials by mixing in some truly superpowered ingredients into our chemical recipe.
So let's start with the classic, a real workhorse coating, nickel-phosphorus, or Ni for short. On its own, it's already pretty good. It's hard, it doesn't corrode easily, it's a really solid starting point. But what if we want to go from just good to, well, super? Well, you do that by creating what's called a nanocomposite. Basically, by mixing these impossibly tiny nanoparticles into the chemical bath, we can whip up a super coating that isn't just good at one or two things, but has a whole menu of amazing properties. We can make it incredibly hard, self-lubricating, magnetic, conductive, you name it, we can probably engineer it.
So, talk is cheap, right? Let's look at what happens in a real-world experiment. Researchers took that standard nickel-phosphorus coating and decided to mix in some tungsten sulfide nanoparticles, and just watch what happens.
Check out the immediate impact. The standard NiP coating, it has a micro hardness, which is just a measure of its toughness, of 539. Okay? Just by adding those nanoparticles into the mix, boom. It jumps all the way to 717. That is a massive improvement, but they weren't finished yet. The next step is a process called annealing, and really all that means is that they bake the coated material at a very specific temperature. What this does is it forces the structure of that coating to reorganize itself at a microscopic level, locking everything into a much, much stronger and more ordered state.
And here it is, this is the result. After that heat treatment, the hardness just skyrockets to 1094. I mean, that's more than double the original coating strength. We've literally just engineered a material to have properties it could never have dreamed of on its own.
So, okay, we've made this incredibly tough material. The obvious next question is, what do we actually do with it? Let's take a look at some real-world situations where being tough is absolutely everything.
I want you to think about the inside of an engine. It is an unbelievably violent place. Parts are under constant attack. One of the biggest problems is something called cavitation. That's when tiny bubbles form and then violently collapse against a surface, literally eating away at the metal over time. This is a perfect job for our new super coating.
And the results are just staggering. By applying this kind of heat-treated coating, researchers found they could reduce the material loss to cavitation damage by about 80%. The coating is basically acting like a shield, protecting the component from this constant microscopic assault.
So, how does this actually work? Well, it's really a beautiful three-step process. First, those nanoparticles act like microscopic bits of rebar, reinforcing the entire structure. Then the heat treatment crystallizes the coating, changing it from a kind of random state into a much stronger, organized one. And the final result? A surface that just refuses to wear down.
But this technology isn't just about brute force and toughness. Its incredible precision and versatility make it absolutely essential for our high-tech world, from the phone in your pocket to massive data centers.
You see, all of our electronics are constantly being hit with invisible signals. It's called electromagnetic interference, or EMI, and this EMI can cause all sorts of problems. The solution is shielding, and it turns out electroless plating provides one of the most effective shields you can possibly imagine.
So instead of using heavy metal boxes like we used to,
Scientists can now take something super lightweight, like carbon fibers, and coat them with a very specific magnetic alloy, in this case, an iron-cobalt-nickel alloy. This creates a material that's both feather-light and an incredibly good shield. And the performance is just wow. This lightweight coated fiber can provide shielding of up to 69.4 decibels. To put that in perspective for you, that means it blocks over 99.9% of all that unwanted electromagnetic noise, keeping the sensitive electronics inside our devices safe and sound. And that is just the tip of the iceberg. Because you can use this process on almost any material, including flexible ones like plastics or fabrics, the possibilities are becoming endless. We're talking about flexible circuits printed directly onto plastic, wearable heaters woven into our clothes, and conductive pathways that can be applied to any 3D shape imaginable.
You know, maybe the most exciting place we're seeing this technology pop up is in the quest for a more sustainable world. From generating clean energy to recycling industrial waste, Electroless plating is becoming a major player.
Imagine this. You take a piece of porous foam, and you coat it with a special metallic alloy. Suddenly, that foam becomes a collection of tiny, ultra-efficient factories. Its huge internal surface area is now covered in catalysts that can do amazing things, like split water to produce clean hydrogen fuel with incredible efficiency.
And this table really tells the story. A simple cobalt iron catalyst, it's okay. If you add some molybdenum, it gets better. But look what happens when you add manganese to the recipe. With that co-FeM alloy, the hydrogen generation rate leaps to an astonishing 11.7 liters per minute per gram of catalyst. That right there is the power of precise chemical design.
And if that wasn't cool enough, check this out. It's a perfect example of circular science. Researchers are now taking the leftover wastewater from these plating processes, which is full of valuable metals, and they're using it to build high-performance materials for new kinds of batteries, like sodium-ion batteries. They're literally turning industrial waste into clean energy technology.
So, from engine parts that last longer, to electronics that work better, to brand new ways of generating clean energy, Electroless plating is this foundational technology that lets us design materials with a specific purpose, right down to the atomic level. It really makes you wonder, if we have this level of control, what impossible problem should we decide to solve next?